Welcome to my garage. Today in this video, we're going to be replacing the batteries in a Dexcom G5 CGM transmitter. I'll show you how to do that from start to finish. First of all, what we're going to need is some kind of abrasive. I like to use this. It's a 3M roll-lock disc. It has these little plastic nubs that do a really good job removing the resin, and they're easy on your hand in case you hit your skin as you're working. When we're finished, we're going to seal it up with this JB Weld Clear Weld 5-minute quick setting epoxy. It does a good job. It's waterproof, and when you cut it off later, if you have to change the batteries again, it's pretty easy to do that. We're going to need some kind of a drill with a sharp drill bit. The size of the drill bit's going to be something like close to what you might have in a screwdriver, because that's how we're going to remove the old batteries from the resin. Some screwdrivers of various sizes, a real small one for scraping. You'll need a sharp razor blade, and a good pair of diagonal cutters. This is a DeWalt pair that I picked up at Home Depot. They work pretty good. Also, for testing purposes, we'll need a multimeter. These are the two that I've got here. This is kind of a less expensive meter. You might recognize it. You can pick it up at Harbor Freight. And this is an older meter that I have. It's a better quality meter from Radio Shack, and I'll show you some of the differences in measuring the output of the transmitter with these two meters. Also, of course, we'll need batteries for a G5. It's these. Renata 389 is the battery for a G5, and then the batteries, if you're doing a G4, are these. They are Maxell SR 1120Ws. Another thing that we're going to need is a paperclip, and I'll show you how we're going to use that to bend our terminals in a way that makes it a better contact. So, to start with, we'll use our abrasive wheel to sand the top of the resin off and expose the batteries. Now, when we're doing this, we need to be careful not to sand through the top terminals of the battery. If you do, that's okay, and I'll show you. I did that on this one. You see the top terminal is missing on the one closer to the bottom, but I don't know how well you can see it on this camera. You see how I've kind of pried it out here? I've gone into the resin a little bit, and I've pried this tab out, which I hope you can see better here. At any rate, right at the tip of my screwdriver, you can see where I've pried that tip out. And I'll show you how to make that work, if that's what happens in your case. Something that I have not been able to make work is this one. The bottom tabs broke off when I was working with them. And I attempted to solder something to the terminal where it goes right onto the board in this cavity. I couldn't get the solder to stick to that tiny piece. I couldn't get that tiny piece hot enough for the solder that I have. I'm sure someone could do it, but I have not been able to do it if you break these bottom terminals off. The terminals, they're good for 2 or 3 bends. Obviously, they did not design these with the idea of batteries being changed in them. So we're doing an off-label work here. So as you're working with those terminals, try to be very careful. They're attached to the circuit board with a very, very small piece of metal. And about 3 bends is all they can take, maybe 4. And that's it. So that's what we'll do. Please be careful as you're doing this. Make sure you wear your safety goggles as you're performing the work so that nothing injures your eyes. So we'll start again by sanding this resin off the top. And since I'm using this type of wheel, I just hold it in my hand. It doesn't hurt my skin if it rubs against it. Now see, as we're getting here, you see the tab on the top of the battery. You're going to want to be real careful as you're sanding this that you don't sand real heavy in this area here, because that's where the terminal bends. And if you do sand that kind of heavy, when you pop it off the battery, it'll just break off. Again, that's not a fatal concern with these, but it's easier if it's intact. So once we get it looking kind of like this, we're going to scrape some of this resin around the batteries. Get it cleared out and scrape it around the terminal. Being very careful not to poke ourselves in the finger. Like that. So now what we'll do is take our razor blade, and I know others have taken a small piece of a hacksaw blade. I'm sure that would work fine as well. But this is really a small area that we need to get into to pry this up. You see, I've just started it here. Just got the razor blade started in between the terminal and the battery. And without having my finger in the way of the razor blade, we'll do some rocking back and forth. And there's one. There's two. There are two small tacks that attach that to the battery. So here I've got that end propped up just a little bit. Do the same with the other battery. If you're doing a G4, by the way, really it's the same. It's the same procedure, just different batteries. There's one tack. There's two. Okay. So now we've got both of these contacts pried up and away from the batteries, like that. Now what we'll do is take our drill. Actually, you know what we can do? Just pry these straight up, because the tension on these really doesn't matter with the way that we're doing it. Again, we're going to want to keep bending these to a minimum so we don't snap them off prematurely. And we'll just bend them both straight up. Go roughly in the middle of the battery. And we'll drill just through the shell of the battery until we hit the paste inside. Once we do that, we'll take one of our small screwdrivers and get it wedged into that hole and use that to pry the battery out of the resin. There we go. Now, see how I've pulled the battery up? Now, it's going to be attached underneath. There's a terminal underneath that you probably can't see real well in this video, but it's tacked on to the battery just like the top one was. So usually, if you look in there, you can kind of determine what the angle it's at. In fact, I believe the angle that it's at is going to be facing toward our top terminal. So if I put a screwdriver in at that same angle, and just gently wedge the battery off of there. There we go. So here's our lower terminal, which is the negative contact of the battery. Here's our upper terminal, or the positive contact. So I'll show you what we'll do with these after I get the second battery out. There we go. Same thing, there's a lower contact. We'll go in with our screwdriver facing our top contact and gently pop the battery off of the lower contact. Again, if you break these lower contacts, I don't know what to tell you. I have not been able to make a success after that. So be careful as possible with those lower ones. Okay, so here we are. Battery is removed. You can see the top and the bottom contacts. So what we'll do now is take our diagonal cutters and we're going to cut these top ones. Give it about that much room. Kind of think about the thickness of the battery and give it a good crimp. If your cutters are sharp enough, you might be able to just snap it off right there. Mine are not. So I make a nice indentation. Makes enough of a weak spot where we can bend it. And 1, 2, 3, well, 5 or 6 bends later, it's popped off. So now it looks like that. Okay? Do the same thing with the other one. It's actually, you can see that there's two points there where it was attached to the battery. We actually want to go just below the second point if possible. These little pieces are sharp, so be careful. Alright, so now it looks like this. We've got the two upper terminals cut shorter. And I'll show you how we'll do the lower terminals. I've got a little piece here stuck on this. That's okay, that'll work. These upper terminals are a little more hardy because they're encased in the resin. They're also attached with a really tiny piece, but because they're encased in the resin, they're a little bit harder to break. Okay, so now we'll take our paper clip and open it up and use our diagonal pliers to bend a tiny 90-degree angle in the end, just like that. And on the lower terminal, you probably can't see in the video, but if you look real close, there are two spots where it has been tacked to the battery. Put this, hook it just under those two tacks and use it to bend the terminal. Use it to bend the terminal over the paper clip, or at least make a spot where you can kink it. You can even kind of force it around the paper clip a little bit. And so now I've curled the end underneath, and I'm going to fold that end carefully while I use my fingernail to keep the rest of it in place. I'm going to fold that end under and smash it down. The reason being, because if we leave it the original length, it goes so far out, it almost touches the other part of the battery, which would make a short circuit and kill the battery right away. Plus, the way we're going to do this other terminal, they'll end up touching, so it's the same problem if we don't do this. So kind of use your screwdriver to fold the sharp end underneath, and then just smash it down on itself. So we're making that lower tab about half the length that it was. So you can see it there. That's what we want it to look like. The sharp end is folded underneath. And then we'll take the top terminal, again bending it as little as possible, and we'll fold that and use a little screwdriver to push it. Oops, well, I broke it. That's okay. I'll show you how to fix that. See, I broke the end off. We'll just take some of that resin that's near the terminal and chip it away. So that we still have a contact there. And I'm just gonna fold this contact a little bit so that it's up against the wall of the cavity. So you can see now I've got my positive contact here, my negative contact here, and when I'm going to press the battery into that when we're ready to do so. So I'll do the same thing on this one, on the other battery cavity. I'll put my paper clip in there just below the two dots, and I'll push down on the outermost edge to roll the edge underneath the paper clip if I can. Take the paper clip out, and I'll keep folding it under as I push down on the top. Make it about half the length. So there's that one. Alright, I'll do the same thing with this terminal. Hopefully not break it. If I do, that's okay. Push it down flat, and use my little screwdriver to tuck it into the corner. Tuck the edge down into the bottom of our cavity. So now this is how I want it to look. I've got this contact here for the positive and this contact here for the negative. So what we'll do now is show how we can use our meter to check some of this stuff. First we'll do an ohms test. Check our leads. Leads have about 0.3 of an ohm. So these batteries are in series, so that means the positive side of one battery connects to the negative side of the other. So the negative side of this should have continuity with the positive side of the other. So there we go. 0.3 of an ohm, just like when I touched my leads. I don't know how well you can see that, but I'm touching one of my leads to this terminal and the other lead to the outer terminal over here. The other two terminals are what's going to go into the device, giving it roughly 3 volts. And let's get our batteries. I'll check the voltage on these batteries just to be sure. You should have roughly 1.5 volts. Positive is on the outside. So I've got 1.595 on that one. 1.593 on that one. Now, the beauty of this setup is I just push these in. The holes are tight enough to hold the battery, and the contacts are right where they need to be. On this one that I broke, I'm going to tuck the contact a little bit into the bottom of the cavity. Because if my contact touches this part of the battery, then we have a problem. It can only touch the outer part. So I'll just fold that little piece of the terminal that's left into the wall a little bit. And then I'm going to just take this and push it in. I'll do the same with this one. Angle it in such a way that I'm up against the one terminal and just mash the other end down in. So there's the finished product. Well, except for the epoxy. So to see if I'm getting some kind of output to the sensor, I'll measure the voltage on these guys here. And as you can see, I've got nothing. So something's wrong. We'll pop this battery out. Maybe I'm not making good contact on one of these things. I can find out if I'm making contact on the bottom of one of the batteries by measuring the voltage, because, like I said, they're in series. So if I go from the back of this battery to this guy here, I should get the battery voltage, which is pretty close right there. So I might not be making contact on this one that I broke. So I'm just going to push that into the wall a little bit farther, into the wall of the cavity, so I get more pressure on it. And I'll pop that in there again. Now let's see what we got. That's what I want. About 215 millivolts. Now, the last one I did said 220. I've seen them say 190 something. I want to show you something though. Okay, this is a Harbor Freight meter, and this is what many of you might be using, and that's fine. We'll switch this to the 200 millivolt scale. Turn it on. Okay, I'll do the same thing. See, this is 19. Now, I've checked this with multiple other meters, fluke meters, other Craftsman meters, Radio Shack meter like we just did. And they all are about 200 and some millivolts. These meters show less because they have low input impedance, which means that it loads the circuit a little bit as it's testing it. So there's not a lot of current coming through there. And that little bit of a load changes the voltage from 200 to 20. So if you have a meter like this, and if it says 19 or 20, on this range it will probably say 19 or 20 without a decimal point. There we go, 19. And on this range, 19.3. It's okay. It just shows a different thing because of how this meter works at really low voltages, really low current. So this was done except for putting epoxy on. So we'll go to the Night Scout X-Strip page and download our X-Strip. This is a fresh copy I've just put on this phone. And we'll go to Settings. Allow permission, sure. Hardware data source is going to be a G5 transmitter. Put in our transmitter ID. It's 40 TPX6. And we go back to here. Start sensor. We'll say we inserted it today, even though we didn't. We're just testing it. Okay. So now we're going to wait a couple of minutes for that to hook up. In the status page, we see it says connection status not connected. That will change as it pairs up with it. You got to give it a few minutes. So we'll set that aside. And I've got one that I already did earlier today. And again, a G5. And we'll put this epoxy on there. We'll mix this stuff up on a piece of newspaper. I like to wear gloves with this stuff because it's really hard to get off of your hands if you get it on. You might want to have a clean rag or two nearby in case you get it on your hands or to wipe off your tools. So this comes in a tube like this. And we'll put some out onto a work surface. You can use a piece of cardboard if you want. Obviously you want it to be something disposable because it'll be ruined once the epoxy dries on it. So we'll mix the two parts, get them nice and mixed up together. And we'll just scoop it on. As long as you're covering both batteries, in good shape. This stuff is just thick enough to settle into a blob, which makes it kind of nice for working with these. Just scoop some up with our little screwdriver and just blob it on there. It'll kind of take its own shape. And once we've got, see, it's nicely covered with the epoxy. Let that dry overnight, and that'll be good to put on in the morning. You can shower with it. It's waterproof. It works. If you put the batteries in and you don't get a voltage reading like we did the first time, try popping one of the batteries out and put it back in. You know, like turn your computer off and on again. It starts the software over again. So that may be all it takes. Let's see if we've connected yet here. Okay, it's a good sign. See how it says Dexcom X6 Auth? That means we got some communication. So we're still scanning. It's still getting information from it. If you want more information on the X strip, we can go to less common settings, view recent errors and warnings, and in here, if you give it a few minutes, one of these things will usually say success, which it has not happened yet. The people that write the X-Strip software are very, very intelligent folks who have done a fantastic job with this X-Strip Plus. So many people have worked hard to make this, and it's really helped a lot of people. There'd be no sense changing these if we didn't have this software to use them. Well, that might take a few more minutes. But it's a good sign because it says it's authenticated. So that's how it's done. If you have any questions, I will try to answer them if you put them in the comments here. I've never had to change the settings on the X-Strip Plus. I know that depends on your phone, and it depends on your firmware of your transmitter. So I'll wait a few minutes and we'll come back to that. So now we've got our firmware on there. This particular one is 10410. Phone service state. Phone got glucose and so forth. Transmitter sent wrong as 0. This isn't good. Well, that's because we're not attached to a sensor. We'll have to put on a sensor and see what it does before we condemn that particular transmitter. But I'll let you know in the notes if this one worked out or not. So, I hope you have success with it. I hope this video has been helpful to you. Thanks for watching, and until next time.